Hello, I am Robert Holmberg from Science Outreach Athabasca, and this presentation is on low light photography. This was part of a series of presentations on a workshop that we used to hold on photography in the night sky. I have recorded a couple other presentations that are useful for all kinds of cameras, but this particular presentation is for more sophisticated cameras that have various controls. So basically it's for a digital SLR or single lens reflex camera that allows you to adjust apertures and shutter speeds and things like that. So here we go. So here's the introduction to low light photography. We're going to talk first about astrophotography in two different forms. We're going to talk about sunrises and sunsets, fog, city lights, vehicle lights, fireworks, lightning, close-up photography, it's sometimes called macro photography, underwater photography, underground photography, and a few other miscellaneous things dealing with low light. So low light, it means that we have limited available light or ambient light. Photographs require light in order to affect the film or sensors. And with low light, you don't have very much. So you've got to increase the light to the camera's sensor. And the first thing that most people think about, most people use, is longer shutter speeds. So with a longer shutter speed, it means that there's more chance for camera movement. And if there's more camera movement, you get blurry photographs. So you have to work around things and make compromises to allow yourself to take a photograph, but also to try and cut down the blurriness. So there's a sort of rule of thumb for using different lenses for cameras, for handheld cameras. So it's that the length of time in seconds is the reciprocal of the length of the lens. So if you have a 50 millimeter lens, the lowest shutter speed that you can use is about 1/50th of a second. And if you have a 200 millimeter lens, it's about 1/200th of a second. So the longer the lens, the faster the shutter speed that that you can possibly use hand holding. So usually that means that low light photography requires a tripod to steady the camera. Okay, the second thing to consider for getting more light is to use a wider aperture. So apertures come in various sizes. The top left shows f/16, which is a very small opening in the diaphragm, and the bottom right shows a f/2.8, which is a much larger opening, and so more light. So one of the things is that people get a little confused with these f numbers, and the aperture is a reciprocal number or a fraction of the diameter of the diaphragm opening. And so the smallest aperture has the largest number. It's like f/16, which is quite small. And different cameras have different kinds of aperture limits. So some cameras the lowest they'll go is f/4, or and other cameras will do f/2.8. But when you're doing larger aperture openings, smaller numbers, it requires more glass in the lens, and those are more expensive lenses. Now, there's a depth of field, or the area that's in focus with a lens. So things that are too close will be out of focus. Things that are too far will be out of focus. There's a depth of field, an area where it has the greatest focus. And the greatest depth of focus is the smallest possible aperture. So an f16 is better than f2.8 for depth of field. Now, the third thing that we talk about to get more light to a sensor is an ISO number, which stands for International Organization of Standardization, which talks about the sensitivity of the sensor in digital cameras or with film in older cameras. So the higher the ISO number, you get more sensitivity, and so you can use it at lower light levels, but on the other hand, it causes more noise or graininess. And here's an example of a photograph on the left with noise and photograph on the right without noise. So the patchiness with noise, clearer colors, less graininess without noise. The fourth thing is to add light. So you can use reflectors to use sunlight to move, reflect it over like a mirror, lamps that are continuous light, or flashes where you have intense light over a very short period of time. So the first thing we're talking about now is astrophotography, or photography of the night sky. And so, as I've said, usually use a tripod to steady the camera and a remote shutter release. And the remote shutter release can be mechanical or electrical or electronic. The first part of astrophotography we'll talk about is short exposures and a fixed focus. And this is relatively short exposures, less than a minute. Which is long for regular photography, but for low light photography, this is relatively short. Okay, now a shorter focal length tends to a larger angle of view, and that means less light per unit area, which means longer exposures. So for an example, if you have an 18mm lens, that requires a longer exposure time than a 50mm lens. So one of the things is you can use a bright subject such as the moon, and you can use the moon to get an image such as this spider web with the moon in the background to light it. Here's a photograph of the moon itself. And most of the photographs I've used in this presentation have got information. So if you want to have an idea of how the photograph was taken, there is the information on the shutter speed, the f-stop, the ISO, etc. And this information is usually found in an EXIF file, which you can access through the simplest way is if you click on a photograph, right click on a photograph and look under properties, you'll find the EXIF information for the photographs, and that'll give you an idea. So this moonshot was shot at only 1/250th of a second at f13 ISO 40 with automatic white balance and a tripod. Okay, here are some tips with it. So we've talked about the tripod with a remote shutter release. Always have a fully charged battery because you're using longer focal lengths. It's usually a little colder at night, so you want to make sure your battery is fully charged. You want your longer focal lens so that you get more light. And then with your camera settings, you put it in manual mode or M for most things that you can do. Focus usually at infinity, wide aperture, a higher ISO, the noise. Some cameras have noise reduction settings, and they do it electronically. This takes time for the processor to do this activity. So sometimes it's good, sometimes it's bad, depending on the camera, depending on the circumstances. And then white balance, usually daylight will be the best, but you might have to play around with that. And then you have to try different shutter speeds. So try 5, then double it to 10, 20, 30, 60 seconds. So we're dealing here with seconds. So here's a picture of the Milky Way, same picture at the front of this thing where I put a line through so you could see it. It's okay, but nothing really quite nice. But if you put, when you're taking pictures of the sky, it's often nice to use some trees or some background to increase the interest in the photograph. So here's a photograph of the Milky Way using a lens that brings the forest around it. Here's one in the mountains of the Milky Way and another Milky Way. And you can see that the foreground looks like it's just about daylight because of the long exposures. Then, of course, you have the northern lights, which are normally green. They move around quite a bit, so you can't get the sharpness that you will actually see at night. It's a little more fuzzy because the lights are moving. And occasionally you can get red in the aurora borealis, like in this photograph. So the next thing about astrophotography is the longer exposures, which leads to motion of, or what we call star trails. And this, we're talking about minutes or hours. So this is a lot more than the seconds that we were talking about previously. So we all know that the Earth rotates 360 degrees over 24 hours, and that translates to about 15 degrees per hour, and this forms the star trails. And Polaris, if you see in the upper right, this right in here, that's the star that doesn't seem to move, the North Star, and everything circles around it in the northern hemisphere. So in the northern hemisphere, the stars seem to rotate east to west, which is counterclockwise. In the southern hemisphere, it's the reverse of that. Okay, here's the tips for a single image, and the white is what we've talked about before. What is different is in yellow. So we're looking at lower ISO settings, lower noise reduction, and again, the shutter release time is 5, 10, 20, 30 minutes rather than seconds. So here's some star trails in a mountain scene. So for a single image, there's problem of light pollution near urban centers and that you get overexposure. So you want to aim your camera a little bit higher. In cold conditions, the battery needs to be kept warm, so you can warm it in next to your body or use a heat pack over the camera lens or wherever to keep the batteries going. Now, the other thing you can do with these kinds of images is to take many short images, short-timed images, and stack them together in a photo manipulation or photo editor program. And so your camera settings are more like what we talked about for the shorter term images, in that they're 30 to 60 seconds to avoid overexposure. Low ISO, noise reduction is usually off because of all the photographs you're taking. And you need the editing program that will allow using layers, such as Adobe Photoshop or the free GIMP programs. And so you would, with these programs, you select the best photo for your base, your first image, and then merge the layers in sequence, one at a time. So this is an example of that sort of thing. And this image is not a star trail. This is actually the International Space Station. So if you get an image of the night sky with a single line, that's some kind of satellite or a meteor. Now, we don't talk about astrophotography with a telescope in this particular workshop, but I'm going to give you a couple of images here to give you an idea of the things that you can take. A nebula, a galaxy. Now we'll move on to the second one with low light, talking about sunrises and sunsets. And these are a bit strange in that you have intense shadow, darkness, as well as intense light in one frame. So you have to be careful of that. So there's a possible eye injury or camera injury if you point your camera directly at the sun. So you should never point your camera at the sun unless it's covered with cloud. Otherwise, you could damage your eyes or the camera itself. So here's the tips. Is because of the higher, some of the higher light intensity, this is one of the low light photography things that may not need a tripod. And you need, if you take your spot meter and focus it on a darker area, then move the camera to compose the photo, then you might not have over or under exposure in the total frame. And the foreground will just about always be in silhouette unless you use a flash. So here's an image in a mountain scene, was quite showing the silhouette of the foreground. Here's an image taken of a sunrise with a telephoto lens on a very small part of the night sky. This one was handheld and done early in the morning. Here's another one done towards sunset on a rocky boat, so I couldn't use a tripod, but you can see there's noise in the dark clouds. The next one we're talking about is fog, and it's got the same things as with sunrises and sunset, is that you can get intense shadow and intense light at the same time. So again, you maybe have to sample more than one location in order to get the exposure that you need to get a good photograph. Here's a photograph early in the morning in fog on the Mississippi River with some barges. Here's a foggy day in Hawaii with a boat moving into Honolulu. The next one is city lights. And here's the tips for those, the same sort of things that we've used for other low light photography. And you can focus or autofocus about a third to a halfway into your scene on an object, and try and pick an object that is about half light and half dark, and a mid-tone so that you get the exposure right. And shutter speeds 10 to 15 seconds. And f-stop of f6 or smaller, low ISO, and your white balance will vary depending on the street lights. So you might try tungsten to get a little bit more blue in a sky, and if they're fluorescents, then you can change it to fluorescent, etc. So you have to judge your photograph. Here's a photograph done with a fisheye lens, and so it's distorting the buildings on the left and the right. Photograph of underside of a bridge. So city light tips, try and get up high, but remember you got to get permission if you're going on the roof of somebody else's building, or get low, like in a river valley. And if you time your photograph about a half hour before or after sunrise, sunset, you can get more detail and color. And park scenes tend to have moving leaves, so you're going to have to use a higher ISO and a larger aperture. such as in this photograph. Here's a Christmas scene with Christmas lights. I love this Ferris wheel. This is a gorgeous photograph. Now, vehicle lights. These make light trails just like we had star trails. Here we have light trails of vehicles. So the same sort of things with tripod, wide angle lenses and whatnot. I again focus near infinity, so you can use autofocus and then set it at manual. You can have a fairly wide aperture range. Try ISO at fairly low, and white balance again depending on the lighting conditions. So you might have white light, or you might have amber light from various street lights. And shutter speed, maybe in the region of 15 seconds. These remember are just suggestions to start off with, and you have to modify them as the scene dictates. Here's a picture of the bridge with streaming lights going to and from it. Okay, there's the tips for just light trails. You're slightly underexposed so you don't get the background. You can increase the length of light trails with the use of neutral density filters that when you have too much light, you can reduce it that way. You can increase cover again by shooting half hour before after sunrise or sunset. Here's another scene of major interchange. And here's some vehicle lights going down a road. So here's some tips for it. Is you can use this with a single vehicle on a country road that has changes in elevation, a hill. So first you should visit the area before dark to choose a location, and for safety's sake, you should have spotters before and after the start and the end points of where you're shooting. They should be in good communication between the driver and the photographer and the safety people. And you gotta have the vehicles go slowly, not fast. So 15 to 20 seconds in the frame. And white balance will depend upon the lights of the vehicle, whether they're tungsten or fluorescent. Here's a picture. I really like this one, sinusoidal curve going down the road. Then we move on to fireworks. And with the tips with them, the same sort of thing with tripods, wide angle lens, et cetera, et cetera. Focus at infinity or near infinity. You aperture f8 to f16, ISO lower regions, white balance set at tungsten. That's the usual colors that are most appropriate. And noise reduction, some people will say should be on. Other people will say that's not true. And then your shutter speed is 2 seconds or more. So here's a shot. And the tips is the fireworks can stay lit for up to 5 seconds. So you don't have to be as fast on the shutter release as you have to be with other things. And you try and get near the beginning of the fireworks, because smoke accumulates and then will cause problems in your composition. And as I said, better be higher up in the horizon so you don't get overexposed of city lights. And if you have experience of what they've done before in the past, it makes it a lot easier of where you position your camera. And you can use something to block the lens, like a black hat or a card, so that you could get several fireworks within one image. So lightning. Now the tips for that is the similar techniques as for fireworks, but you need longer exposures or an electronic shutter release specifically designed for catching lightning shots in order to catch it, because they occur very, very quickly, and by the time you recognize that it's occurring and you press the shutter release, you're not going to get it. And you're going to have to deal with rain and wind usually when you have lightning, so it's a stormy kind of condition. And you've got to be safe. As seen in this photograph, the person was trying to photograph lightning in this lit up oil derrick, and in between there was a tornado. So you've got to be careful. Okay, close up or macro photography. So this is when you're taking a 1-to-1 or higher magnification, and you're going to have to use a smaller aperture because of getting the largest depth of field that you possibly can. And your camera often gets in the road of light, and so you might have to use auxiliary lamps or flash. And to prevent camera motion, you need a tripod or external flashes. And some tripods will get very low and some will not. And external flashes, because the flash is so short a period of time, it reduces what you would have for camera shake. So there's various modifications that you can make with magnifying screw-on lenses, reverse lens mounts, extension tubes and bellows and things like that. But also there are macro lenses that are designed for close-up work. And those are the easiest to play around with, but more expensive. So here's a photograph. The hairs on that are the hairs of my finger. So you can see this is a very, very small spider. So, as I said, you can use a simple magnifying lens to go over your regular lens to get a little bit of magnification, or you can attach it to some kind of microscope. And the big problem with this is actually finding a coupling device that will fit your camera and will fit the microscope. Here's another very complicated handheld device for getting close to, say, insects or flowers. Now, if your subject is immobile as this preserved spider, you can take several images at different focal positions, and then merge them into a single image. Now, underwater subjects. So with these things, you have to remember that water absorbs lights very, very quickly. And so you have to use larger apertures and on higher ISOs, but you still have to use a high shutter speed, because if you're underwater, you're usually moving and the subject is moving, and otherwise it gets very blurry. The other thing is you have to realize is that the reds and the yellows get filtered out very, very quickly, and the greens and the blues less quickly. And so there's always a color shift if you get very, very deep in water. So in this photograph on the left, lower left side, you can see some coral and fish that are in a relatively little depth. And to the upper right, you can see that it's going into the blues and greens because that's deeper water. So to do these, you have to snorkel or can scuba dive. And with this, you've got to use an underwater housing or an underwater camera. Underwater housings cost about $1,000 for a single lens SLR, a single lens reflex camera, and they don't last for more than a few years before the seals break and you use your camera. So I tend to use cameras that are designed for underwater, and these days they're relatively cheap and quite good. Okay, so you have to pick a day after a period of calmness so that you don't get a lot of wave action. As I said, both you and the subject will be moving. And usually, as I say, you require fairly fast shutter speed, wide aperture, and a high ISO. So sunny, calm days give you the most light. Wave action will reduce light, and cloudiness will reduce light. And if you're going into deeper water with scuba equipment, you're going to require flashes or strobes. And one of the problems with those is that in marine situations, especially, there are small particles that are floating throughout the water column. And with strobes and flashes, they will reflect back and it looks like it's snowing. This was taken as I was just climbing out of the water, looking down, and these counter rays went by, and there was enough light, but you can see quite a bit of noise in the background. But a simpler way of getting underwater photographs is go to an aquarium, and there's lots of things you can see and photograph in aquarium. So they usually have low light to prevent algal growth and disturbing some animals and whatnot. So if you can, a tripod would be great. Some places won't allow you to have tripods because of tripping factors. You might be able to get by with a monopod. You got to shoot at an angle to the glass or the plastic so that you can avoid reflection. You can use a polarized filter to reduce reflection, but it also reduces light. And a rubber lens cap can be used right against the glass, and that will eliminate a lot of the reflections. And sometimes flashes are allowed, but usually not. If you do use them, you should angle them to the glass, not directly on. So this is a leafy sea dragon that wandered just underneath the light, but you can see the background has lots of noise. This was also in an aquarium because the anemone was close to the glass. Then when you go underground in mines and caves and things like that, there's no light. So you're always going to have auxiliary light of some description. And there's going to be color adjustments depending on the light source that you use. And it's going to be probably wet and muddy. So be prepared for that. Okay, now we're going to move into the miscellaneous section that I have here. We're talking about pendulums, deliberate camera movement, painting with light, and flames. So this is what you can get with a pendulum, and a lot of the settings are the same as we talked about before, except that using raw files are usually better to be able to edit for color. So these are the various tips. Is use a string on the ceiling and a tripod to hold your camera below on the floor, sort of pointed up at the ceiling, and a single light LED if you can get it these days. You center the pendulum over the lens. The thickness of the photograph varies with the aperture. So if you want fine lines, you have to use something like an f/16. You push the string in a circle to get spirals of various kinds. And when the flashlight circles are in the desired diameter that you want, then you release the shutter. And again, with a coded or electronic shutter release. And you're going to have to do this several times before you get a good shot. Here's an extraordinary one. You can also deliberately move your camera and use low shutter speeds. This was taken of city lights, and I moved the camera from the bottom left and up and got those sort of wiggly lines. Here's another one with buildings and light in, this was done in wintertime, and so there was some exhaust from cars that made the foggy appearance, and exhaust from smoke. Okay, then we are painting with light, and this is when you add light with some device like a flashlight. So again, manual mode, ISA fairly high, aperture sort of medium, 30 plus seconds is what you normally require. If if you use noise reduction, it may double your exposure times. So here's done by one of the participants in our workshop. I Love You, carved out with headlamps, red headlamps. This is done with a firefighter dressed in firefighting equipment, spinning around a cage filled with burning steel wool. Do not do this without proper protection. This was published in National Geographic magazine, where somebody took a long time to take a pen light and go through a kitchen and cover everything, including somebody laying on the floor. I do not understand how they got the two flower vases, unless they used extra light to illuminate them. Okay, to paint with light, you have to use a high power flashlight to illuminate the subject, like a tree or barn. And this is a photograph of one of these huge flashlights. And don't point the light at the camera lens, or you're going to overexpose it for sure. And keep moving unless you want to be part of the photograph yourself. So here is an old farmhouse painted with a flashlight, with the moon shining in through clouds in the background. This is a photograph showing myself illuminating the trees with AU for Athabasca University, and it's a kind of a double exposure because I'm shown twice in the same photograph. One of the things that we did with our workshop is have the participants shoot a scene lit entirely by one candle. And here's an example of what you can do with a single camera flame, no other light. But with fire or flames, again, you have the intense shadow and intense light at the same time. And because flames are hot, you got to keep you and the camera back from the heat. So a telephoto lens is useful. And you probably have to use manual focus because the flames are moving all the time. Here's a shot of some burning logs. Oops, and I went too far. These are acknowledgements. I've taken photographs from various other sources and used some photographs from the participants in the workshop. So I hope these ideas will give you some idea of what you can do. And there's all kinds of videos that you can look to pick something that you want to specialize in and try it out in more detail. Thank you for your attention.